Hey guys, this is Sanjay from FTC Team 7477, Super 7. Today, I'm going to be talking about HeapSort in Java. HeapSort is a powerful sorting algorithm that uses the properties of binary heaps to efficiently sort an array. In this video, we'll go through the code and we'll explain how it works line by line. So let's start. Let's start with the main HeapSort method. I'll just code this pretty quickly. Or not I plus plus I minus. You can see that it kind of goes in reverse from most normal for loops, as usually I is less than a number, but since it's greater than, usually I increments and it's minusing. We'll get to as to why this is how it is in just a bit. By the way, heapify, I just call it that because it sounds, it's pretty much turning the array into a heap, which is what it's called. We'll get more in depth into this method soon. Right now, I'll just finish implementing the actual heap sort method. Alright, so first, this is the heap sort method. It performs heap sort on an array and it sorts it in ascending order. The method consists of two main steps: building the heap from the input array and extracting elements from the heap one by one and adjusting the heap accordingly. So let's talk about this first for loop. For into I equals n minus 2, n over 2 minus 1, I is greater than or equal to 0, I increments by -1 each time. So the first step is building a max heap. A max heap is a binary tree where each parent node is greater than or equal to its child nodes. We'll make a video on binary trees soon, but a, but a binary tree is essentially just a big tree with nodes attached to each other in a way such that you can make connections and extract data from it. So the for loop starts from the last non-leaf roots, which is at index n minus 2, n over 2 minus 1, sorry, and it moves backwards to the root of the heap at index 0. For each node, we call the heapify method, which essentially turns something into a heap, which we'll get into soon. We call the heapify method to ensure that the max heap is properly maintained. By the end of this loop, the array is organized as a max heap. Oh, sorry. This is supposed to be in this for loop. Coded it wrong. Alright. So now let's move on to the next for loop. For int I equals n minus 1, I is greater than 0, and I minus minus. Once the heap is built, the sorting actually begins. The second loop starts at the last the second loop starts at the last element of the array and works its way backwards. At each step, we swap the root of the heap, which is the largest element, with the last element in the unsorted portion of the array. Then we call heapify to restore the heap properly for the reduced heap. Lots of heaps around here. Next, let's go on to the actual heapify method. I'll just program this. The declaration of heapify is somewhat similar to merge sort, as instead of taking only one input, the array, like other algorithms such as quicksort or bubble sort, it actually takes three, just like merge sort. Oh, this is int I, not int j. Alright, so let's go. Alright, so if left. Another thing I want to talk about in the HeapSort method that I didn't get to mention, it actually has a similar switch block statement. Like, it's pretty similar to other sorting algorithms like quicksort, but it also has some elements of merge sort, such as having a whole separate method to sort recursively inside here. So HeapSort it's kind of like the best of both worlds. It's complex, but it also has some switch statements, which makes it a bit easier to program and debug. So now let's really talk about the heapify method. The heapify method is known, sorry for a semicolon, heapify method is known as the heart of HeapSort. It ensures that the subtree rooted at a given index maintains the max heap property. Let's break this method down. The variable largest starts at the root of the subtree, which is I. We calculate the indices of the left and right children using the formula 2 times I plus 1 and 2 times I plus 2. We compare this root with his left and right children to find the largest value among them. If the largest value is not the root, we swap the values and recursively call heapify, which is this part. We recursively call heapify on the affected subtree to ensure the max heap property is maintained. Now let's go to the actual implementation. So let's declare our array. So if int r, let's see some random numbers in no particular order. Alright, so we have some random numbers, right? So we can call heap sort on array on our array. Oh, sorry. Yeah, I actually don't need to define it since it already is not here. Sorry. So now let's go print this at 4 int k equals 0 just to avoid potential scope issues. So an r dot length k plus plus s out, which is IntelliJ's shortcut for system.out.println r of k, right? So let's run this code. Just like that, everything sorted nicely and neatly. To recap, HeapSort is a comparison-based sorting algorithm that uses a binary heap to sort an array efficiently. The two key steps are building the actual heap and extracting elements and maintaining the heap properly. HeapSort has a time complexity of O n log n. So big O of n, yeah, alright, n log n, which is the same as merge sort, which makes it a reliable and efficient sorting algorithm for many applications. Thank you guys for watching the Super 7 programming tutorial, and make sure to be updated for more future content releases.